welcome to the workshop dedicated to contributing to Gradle. So at the end of the session, I want to have a pull request. Actually, no, I want to have that pull request merged. So that's going to be the second half of that. Well, now, most of the time, I hope that we'll be coding. For the first part, I'll be talking. That's how it's going to work. So there's going to be Luke Daley soon, helping out. Luke Daley, our very own, is one of the greatest engineers I've ever worked with. So he's the mastermind behind the plugin portal. So, and the best way to have some nice features in Gradle is just to cut loose like Luke Daley on the code base, and yeah, they're just popping up, nice features. So we want to train you in contributing to Gradle. And while I'm talking about things and how to do that, you can download IntelliJ 13, and you can sign up with GitHub for Gradle and clone your fork onto your laptop. And I'm going to push you to some pairing later on, so be ready for that. So what to contribute, that's the first thing. So there's always some feature that you want to do, right? I had two features I remember that I always wanted to implement when I joined Gradle. One of them was task ordering rules. So Hans showed that at his keynote, like must run after, should run after, those methods in our API to control or influence the task ordering. Now, that's something I always wanted to do, and testing framework for Gradle plugins, another thing. What about you? What's the feature you always missed in Gradle, or you wanted to do? Anyone has something?
How long is the session?
All right, yeah.
Parent palms.
Parent palms.
Yeah.
Yeah, that's one of them.
I mean, for an external project that exposes parent palms.
So parent palms is so there are like a set of use cases that parent palm implements in the Maven world. So we could find some ways to tackle those use cases in the Gradle way, which means more flexible and nicer and cooler.
Or even just, yeah, okay.
So maybe Gradle Summit 2015, during that session, we'll do the parent palms. We're gonna tackle a smaller feature this time. There might be also some problem that you always wanted to fix, right? If you just want to contribute, there are people like that. So give me stuff to work so that I can earn the eternal fame of open source contributor. So you can always touch base with us. So there's a dev list. I guess it's the best place to discuss if you know things already about Gradle. So it's more technical, it's more for experienced guys, I guess. There's also forums, mostly used often by newbies, by Gradle newbies, to ask basic questions. But also it should be good for discussion, communication. Here's our use case, here's the problem that we want to solve, and help us, and then we can continue that discussion. Discussion about features often ends up in design specs. So this is the concept we have introduced. It's design spec is a document, is a text document that lives in our GitHub repository, and it contains all the thought process that happens before we start implementing the feature. So I'm going to discuss design specs in further details. In general, we care very much for designing features. We believe that it's very important to think through the feature before we implement it. Actually, it's not about even a feature. We want to think through the use cases. We want to gather those use cases. We want to abstract them. We want to merge them. We want to really drill them down in order to find the best solution to the problem. So there are open source tools and libraries out there where maintainers do, hey, let's do this feature. All right, and it's released, right? So good luck with this kind of approach. We are opinionated. We sometimes believe that we look for the best solutions to the problems. This approach sometimes may not be as good, I guess. Canonical example is provided scope, right? Let's not start discussing that. So we always thought that is a grand solution for provided, and there is. But in my opinion, we could have provided something. We could have provided something simple, like an incremental step that wouldn't stop us from having the grand solution later, but could relieve some pains for the users now. Another thing important for before we implement features is we prefer to focus on use cases first. Often we receive feedback from our users or even contributions that there's already a solution. Hey guys, I have this problem, here's the solution, blah, 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 blah. Now we much more prefer to receive use cases, and then we want to cooperate on finding the solution. So use case first. It's obviously allowed to do a lot of spiking during the design. So when we design features, it does not mean that we spend a week just thinking about stuff. We tend to be close to the code, so we spike a lot. We do a little bit experiment with the code, and I do that a lot. So when I write the design specs, I very often write a little bit code and change stuff. If you want to interrupt, then just
just to expand on Szczepan's point there about contributions and the difference between sort of features and use cases. It's really quite a natural thing and quite common and makes complete sense that most contributions are around somebody having a particular problem in a particular context. They find the solution to that and they feed that solution back in. But what Szczepan's kind of getting at is that a lot of the times when we look at it with a larger kind of context, we can see that that particular solution isn't quite going to fit. That's why we try and push back a little bit on that and say, okay, let's work with the person and consider it larger. Now that's often, there's a tension there between what we want to achieve and what the person who just wants to fix their problem and move on wants to do. So we kind of just have to compromise there that if you're in that situation, you're trying to contribute that feature in order to get that fix in, we just have to massage it and rework it that way a little bit. So just wanted to add a bit of context to that. Yeah.
Perfect. Thank you. Maybe I'll show a little bit of a design spec now in our GitHub repository. If I go to Gradle GitHub repository, there is a design docs directory, and we have a bunch of markdown files. So let's find the model, the configuration model, project configuration model. So those are the things that we plan to do. Adam talked about that this morning, about those features. So there's a design spec. It's more detailed. Design specs describe use cases. They describe the test coverage that we want to have. They describe initial implementation plan that obviously can change. While in the field doing the feature, often we find out that initial implementation plan wouldn't work, but that's okay. Yeah, it also may contain some problems or questions, things that we haven't yet think through, but we don't want to forget about them. Okay. Sure.
So just a little bit more on that. I've had this feedback from a few people who have looked at those documents and said they make no sense whatsoever. Right? And one of the reasons for that is that it's really an iterative brain dump from the people designing the feature as the ideas are coming together with them. So it's not as if we sit in some other room, design everything, then dump out these documents. These are kind of the work in progress as we're going. It's why they're not always coherent, and hopefully over time, as you see the work on them come in, they get better. So that's something just to keep in mind as we do it. And one of the reasons for that is that we try, we're all a distributed team, we work in different time zones, we very rarely have face-to-face time with each other. So this is the shared vision of what we're going to do. So as people are working on these documents, other people from the team are reading them, etc., and working on it collaboratively. So you're going to have to look at it through that lens, not a final description of this is what the plan is. It's always in a living document.
In our engineering process, we even have this rule that we always listen to changes through the design specs. Like when Adam does changes, Luke does changes, so it's our rule that everyone should take a look at those changes. And as Luke says, not every design spec is perfected, and there might be some things that are out of date. But this is our way to ensure that we think through the features before we get to implement them, and our way to to work collaboratively on them in a distributed team. How do we decide when they're done?
So one tool that we don't have public is our Trello board. And that's really a Gradleware organization tool. And that's what we use to track this. So if I have a design spec that I'm taking the lead on, then I nominate in that tool, that this design spec is still in progress. I'm still working on it. And at some point I will say, well, I think I'm done here. I'll move it into a review column. And then typically Adam or whoever else is kind of going to be the primary reviewer on that stream will then take a look at it and it will flip back and forward between those. So really, now realizing that wasn't quite your question. So when is it good enough, I guess is the question you're asking more so? Yeah. When we think we know enough to get started and we're reasonably confident this is the right way to do it. We don't plan it out till the end because that's a design up front and that doesn't work, right? But we try and term this enough design up front so that we don't just drive straight into the code, go start tearing things up and then realize that was a really bad idea to begin with. So there's no real kind of rule or hard limit on that. It's just a sense of it, and when we get enough agreement between everybody that yes, this sounds like a good plan, it looks like there's enough test coverage there built in. One thing that we didn't quite show there, which is a real key thing in the design specs, is how we're going to test this. What things do we need to check off to say that this works and therefore it's done? So once, more or less, that's what we care about the most, I guess, because we don't, how the feature is actually implemented. We're all kind of adult engineers, I guess, and that's more or less up to us. All we have to do is, if there's enough there does it satisfy the use case and does it work? So this is the test coverage we're going to have, and this is the use case I'm trying to hit. The actual, okay, we're going to call this class this and blah, 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 that's for when you're writing the code. Yeah. So I guess the short answer to that question is when we think, yes, that's a valid use case, yes, if you have all that test coverage implemented, then we'll be happy with it.
So someone coming from the community can contribute to one of those existing documents as well?
Yes.
Absolutely.
So, yeah, community is welcome to contribute to the design spec as well. So the question was whether external contributors can contribute to the design docs. Yes, they can. Yep. So this is an example here. We have some standard sections in the design spec, like user visible changes, that's first, test coverage, that's important.
Good example, Szczepan.
Not a good, like the TBD.
Sad day cases, TBD.
TBD, no, there are no sad day cases. Yeah, so it's working in production in the future. So, go ahead.
So to contribute to the design specs, we do that through a pull request?
Yes.
Yep. So there's really two kinds of contribution to this in terms of content, but probably more relevant is the discussion. Say, well, I don't agree with that, or have you considered this, that kind of thing. That tends to happen two ways. One, you can commit on the changes in GitHub. Anybody can do that because this is all a freely open source repository. The other is emailing the dev list and saying, hey, I just saw this design spec go past. I have these thoughts on it. And quite a lot of work has come out that way. And in many cases, features have happened faster because people have done that. And kind of when we get pushed from the outside to do something, that kind of raises it up in the priority list to do it. So yeah, two ways, commenting on it via the dev list and directly in GitHub as well. It's less common to get actual content for the design specs done because I probably don't need to tell you, but no one really likes writing documentation, right? So.
The design specs are also influenced by agile project planning, and very often, like the high-level section that you see here, are user stories that we implement and we internally manage, so that someone is taking over a user stories, he's working on that. Yeah, final question, do bugs require design specs? Probably not. Like, I guess it depends on the bug, but probably not, yeah. Okay, so the process, there's a CLA process, maybe Luke will be a better person to describe that. This is, for the legal reasons, it's necessary for contributors to sign a certain document so that the code they write can be distributed to everyone and everyone can take advantage of that. Not sure if there's anything else.
So we hate it, right? We don't want to have this at all, but we have to protect ourselves at all. And it's an inconvenience. I know if you just want to get one line change in, legally we can't pull it in. We take risk on if we take in that work without having somebody said, yes, you can go ahead and use it. So it's just a requirement. We're trying to work out ways to make this easier, make it fully digital, etc. at the moment. So at the moment, follow a link, print out a form, scan it, email it back to us, or mail it back to us. It's a bit of a pain, but you do it once, that covers all contributions you make in the future. So we just have to do it. So the question was, do we have a stack of them here with us today? That was a good idea. Yeah.
But then you have to commit that you're gonna deliver some feature by like end of quarter or something like that. So. Okay, so and then the process. Yeah, go ahead.
With that is that, do you sign as an individual? Do you sign it under a company? Like within Java,
At the moment, it's purely on an individual basis, and part of the contract is that. All good? Oh, sorry. Okay. Question: is the CLA on an individual or organisation basis? At the moment, the public CLA process that you follow through GitHub is purely on an individual basis, and there are what's the word? Parts of the contract that you are kind of vouching that you, in your whatever context you're operating in, have permission to do it, which covers us from your organisation turning around and saying, no, I didn't permit that person to do it. Right, and to some extent, as much as we can be covered, it's then the person in the middle's responsibility. On the other hand, we do have some organisation-wide agreements with some of the big companies we work with. So that's a separate kind of process that we deal with. Yeah.
Okay, any other questions? Okay, cool. So the remaining part of the process is the standard GitHub pull request, which means that you need to fork Gradle, you implement feature in your fork, and you create the pull request. So. Yeah. Anyone has done that? Anyone has already done the pull request?
Anybody not used to the pull request model, doesn't know how this works in GitHub.
Okay, so a few people.
Yep.
Is there anyone who does not have a GitHub account at all? So everyone has. It seems everyone has. Okay, cool.
What about kind of backwards compatibility? I mean, let's say if there's 12 branches. Well, there's a ton of branches, but there's 12 releases, and that's on the 1.0, and now there's 2.0. So how does that work? Do things get ported back, or is let's say you make a contribution, do you then go back and do that to all the branches, or?
So the question was backwards compatibility and I guess backporting changes to multiple branches. The answer is we avoid that at absolutely all costs. Right? We haven't had the situation we've had to do that yet. We work on master. We have a stable release branch that we branch just prior. Are you going into this in any more detail later on? No. Okay, so a stable release branch that we kind of just before the RC phase will do that, and then basically stabilize that, do any final work if we need to. But it's a single branch model. We don't do multiple branch development at all, so you don't have to worry about it. Just commit to master. Yep.
We only use the release branch so that people can freely develop on master things that are, let's say, half-baked. They can have nice incremental progress. But I guess in theory, but we don't do feature branches, stuff like we don't, okay, any other questions?
So you want to just get with the UI forking?
unless there's more than just me.
Let's do that. Let's do fork, but maybe later. Okay? Yeah. Okay. So a few words on the criteria for the submission when you are working on stuff. So you need to write a lot of tests, right? We have unit tests and integration tests, coverage, very nice, already existing in Gradle. So we want you to also do that. So remember about that. There's a user guide that I guess I would recommend mainly for like fresh users, new users, to read through that stuff, go through the samples. Then depending on the feature, but if the feature is, let's say, like big enough, then it requires some changes in the user guide. So it would be nice if the submission also included changes in the user guide. There's a Java doc. Obviously, if you change the APIs or introduce new APIs, please document those changes. There's a DSL reference, which documents the build language. Actually, let's have a quick look. This is also something that you want to contribute, but it depends on the feature, right? If the feature introduces new APIs, chances that you need to update the DSL reference. What else we have here? We have release notes. So release notes live in the GitHub repository. So Years ago, we had a wiki page for the release notes. I remember Luke was one of the who were pushing us hard to push the release notes to the GitHub repository. I was one of the guys who say, maybe not. Wiki is so easy to edit. Once the release is done and something needs to be tweaked in the release notes, very easy to go to the wiki page. But wiki page didn't work for us very well. It was too detached from the source. We wanted to work continuously. When we work on a feature, we write a little bit of tests, we write a little bit of implementation, we write a little bit of documentation, release notes. This happens continuously. Therefore, we don't forget about the things that we have done so that to include them in the release notes. So release notes are, let's take a look in the GitHub repository. So it's sub-projects, docs. We actually can take a look at the release notes for the current master. So docs, release, and then notes. So we have some, nothing yet. This one is boilerplate, yeah. But generally, release notes are in the code, and when we work on things, we update the release notes. Successful pull request that we merge with the smile contains all those changes, including release notes. We often, before we release, we also mention contributors in the release notes so that you can get that fame. So, yeah. And then you need to write more tests and finally the code, which has to be clean, obviously.
So yeah, it's been a surprisingly successful strategy and cheap strategy for us to just give contributors more presence and make it more prominent within our release notes. It works for me if I contribute to a project and they mention that I contribute to it. I'm more inclined to keep contributing to it, right? So that's easy. But in terms of Szczepan's talking about the submission criteria, the documentation, things like that, I don't want you to get the impression that before you submit the very first change, it should include all these things. Right, this is something we can work iteratively with over the pull request and add them later. So what we wouldn't like to see is somebody out of the blue sends us something and here's all the code, here's all the documentation, here's all the tests. That it might be exactly what we want and we end up with, but chances are it's probably not going to be. So a better approach would just be to do this iteratively. Send in the code, but just be prepared that we will say, we're likely to say, well, we can't pull this in until there's documentation and add that as a next step in these kinds of things. So this isn't the bar to first submission, it's just kind of getting it into the code eventually.
Thanks. Good point, Luke. Thank you very much. So some hints for the successful contributions that get into the master. So first, when we start designing the feature, remember to deliver as use cases rather than the solutions. And when you have a use case, you can attack us with that already. So you don't have to spike that, implement that. You can start discussing with us the use case, the problem. Yeah, so be patient and be ready to rework some things with us. So because we are opinionated sometimes. We tried not to be dogmatic, but we have some vision. Adam has some vision, and Gradle wouldn't be where it is right now if we just let the things flow in a way everyone wants. We have to have some kind of a common vision that wraps every contribution. Everything has to be reasonable. So yeah, you need tests and docs. Ensure the build is happy. So contributions that make the build unhappy makes us unhappy. Clean code, and yeah, you please say that you love Gradle all the time. Be friendly to us, and the chances rise for the merge to the master. Anything?
So, just a couple of things on that. We do have some things in place. I'm not sure how much we're going to go into this, but when you send us a pull request, that's right. I was just trying to remember what I was going to talk about. Yes, ensure the build is happy. This can sometimes be a bit tricky, ironically. The full build takes a long time to run, so typically that's not what we're talking about. But when you send us pull requests via GitHub, we have a process that runs the kind of minimal set of tests and will give you feedback on that. Also, the contributing documentation has some hints on the kinds of things you can run in the build, and we're going to go through that as well, I guess, how we can run those tests. So we try and craft this process around giving you a lot of feedback and help on that, I guess.
Cool. Any questions? Okay, so we're gonna get new feature into Gradle. So enough of talking. Let's start discussing some things. So I want everyone to set up. So anyone already has a Gradle fork? Oh, many of you. Awesome. So maybe that's going to be faster. Okay, cool. So I want you to fork our GitHub repository, clone that to your local laptop, and start building. And yeah, we're going to install Gradle locally. I'm going to do some things on my laptop so that you can see what's happening, but I would like you to follow. And then once we have that, I'll describe what we are going to develop. What time it is? Half hour. Okay, cool. So there you go. Go fork your GitHub repo, and I'll be doing that as well. Well, actually, I'm not going to fork, but I'm going to show you the UI for that. Any questions you might have? Okay. So,
do you suggest building with Java 6, 7, 8?
you should be able to build with any. Whatever you have should work. Currently, our test infrastructure uses, I think, at least 1.6. So, yeah. Okay. So, to clone the repository, you go to the project. And there should be some. I've already.
Sorry, on the Java version, what compatibility do you need to be? Assume that you shouldn't use feature from something that you guys aren't.
Okay, so the question was about the Java compatibility. So currently, it is possible to work with Gradle build either with Java 1.6 or 1.7. I'm not sure if 1.5 is supported in a way you can build Gradle. I don't think. Yeah. But you can build Gradle with 1.6 or 1.7. Our distribution is built with 1.7 because this way we can use some of the 1.7 features. So you can't really build a production-ready Gradle with 1.6, although it will be enough for like local testing and building locally, just running it. It should work. Anything you want to add?
Just one mechanical thing about the building. Not to that, though.
Okay, so let's clone the repository. So I don't remember where you do that actually. Oh yeah, so you fork. So there's this thingy here in GitHub. You fork Gradle. I have already forked that. Not sure how long does it take. Hopefully not too long. And once it is forked, let me try what happens. Let's fork this. I already have a fork. And then you grab the URL so that you can clone that. Yeah. So let's clone that. Once you have that, I'm gonna just walk the room to help you out in case. Okay, let's go to Gradle. And then in the meantime, I'm gonna go to my source. So I'm not gonna fork it. I'm gonna use master version, but you please do fork and clone that fork so that we can actually do this pull request. I really want to do this pull request today so we can merge it. I even got a blessing from Adam on this idea, so it makes perfect sense. When I flew here, I didn't know if it's going to be blessed and all good, but it is, so nice. Okay, so once you have cloned, I want you to install Gradle locally. So to install Gradle locally, you want to run the Gradle install task.
Before this?
Mm-hmm. Yep.
So our build has quite a lot of dependencies that when you run this for the first time, you don't have those cached. It's going to download a lot, right? And this is a problem on Conference Network. So Freddie's got a local Artifactory instance happening. So we're going to make a small change to the build. So instead of downloading from the internet, we're going to download from his laptop and hopefully melt it. So what we need to do, .com/Freddie33.
Justin as a hack. Hopefully it's going to be fast enough. Yeah, you really need everything.
What's happening?
An init script to take out your Maven Central references and replace it with this. So just sort of like
We have Maven Central references?
or just any repository
Okay.
references to point to his.
Yeah.
So
Gotcha. Okay, let's do it.
I'm close, but
This one works. But
All right,
no,
so let's do this.
Because
So-
he has the three. They have three. They have Maven Central, Maven Nether Leaves.
you only want the greater height.
Okay, so we need to make a local patch to our builds to avoid this problem, right? So the root build.gradle, if you go to your checkout, you'll see a whole bunch of things, a bunch of files. If we open up the build.gradle file, it would be simplest to do this with some kind of text editor right now, and we're going to get this into IDEA in a little bit. But we need to open up the main build.gradle file. I'm going to use Vi, use a text editor or something, whatever you want to do. All right, so I've opened up the root build.gradle. Let's do a search, however, for repositories.
You already have a fork from a long time ago? All right, go to the compare.
Okay, so we want to find this line here.
Nothing to update on yours. And then say switch.
In the root build.gradle.
You'll see there's like a link.
And we want to replace that with this.
Switch the base.
Uh,
Yeah.
Freddy, localhost?
And then it'll
That's not going to work.
Wow.
Wondering how that was gonna.
I'm missing Control S on my.
So don't do this, but something similar.
So are we doing this trick with the URL?
Yep. So root build.gradle, open it up, go to the repositories block. Okay, so that line which is maven URL repo.gradle.org, we want to replace with this green one here.
mirrors.
Anybody not know what we're doing right now?
So what you been telling? So raise your hand if you need any help. Right? I'll walk in.
So you know install requires that property to be set, right?
So that build will fail at the same
Okay,
time.
cool.
So,
I didn't know that.
come again?
I didn't know that. Okay, you want to take over?
Cool.
What's it do? How are things for you guys?
Oh, we just updated like earlier and stuff, so.
Beautiful.
It's good.
Okay, so we're gonna progress slowly, but feel free to raise your hand and maybe me or Luke will come over to help you out. Okay, so installing Gradle locally. Okay, so where am I? Okay, Gradle. So I want you to run the install task. If it fails, don't worry, just read the message, all right, and fix according to the message. It's not gonna fail for me. You see the warnings, right? Those not our real warnings.
Install is doing build.
Come again?
Install is doing a build or it's a short term?
So install does not do full build in terms of like checking, running tests. Install builds binaries, place them in into a specific location on your disk, so that you can use Gradle, and then you put that on path, and you can use Gradle. That particular version of Gradle that has been built, you can use.
Is Gradle install path a system property?
Is Gradle what?
Install path a system property?
It's a project property.
Project property.
Yes, so you need to pass. Okay, so some of you has already reached the point that install complains that the project property is not set. So let me actually demonstrate that. I do have a Gradle properties file that has Gradle install path, which is there. But if I don't have that and I do Gradle install, the build is going to complain saying that you didn't tell me where to install. So just pass the project property. You can either drop it to Gradle properties file that you can put in your home /.gradle properties, or just pass it from the command line. Okay, so that's the failure. And maybe it's easiest to just pass it through the command line -p, Gradle install path. And then let's say Gradle, I'm going to put it here in the master. And that's going to install binaries. So that's a minimal thing that you need to do to get Gradle built locally, and you can use that version. So that so you can, let's say, make some changes in Gradle, build it locally, and now you can use it. Right? I'm going to show you better ways of doing of checking whether your changes to Gradle work. But for now, I want you to get the Gradle installed. Hey, build successful. Anyone has a successful build of installation of Gradle already? Not yet. Still downloading, still building, downloading stuff.
So does configure on demand, parallel, any, do these work on core?
Now we do have too many illegal project couplings in our own in our own build that we can't do. But we have very nice integration tests for configure on demand, and for we have all our integration tests are executed with parallel feature. So that's so we have pretty nice coverage for those features, even though we don't dogfood them that eagerly in our own build. Obviously, we should.
Just to not leave that comment hanging, we experiment a lot with Gradle in our own build, so it's not a good reference build for a lot of things. We kind of spike things out and try things, so I wouldn't necessarily consider it best practice in a lot of ways, what we do. But it's informative for us to do it. Sorry? Master, yep. Yep. Always work on master. Yep. So the question was, what are we cloning right now? So it's 2.1. Yeah. So master is currently 2.1. The release branch has 2.0. Yeah.
So let me just show how I did that. So you can see that instruction there.
Okay, if you have that done and you're going to be using IDEA, IntelliJ IDEA, then just run /Gradle W space IDEA. Yes, no?
Okay, I think we can go slowly forward, and we're going to be helping out, no worries. So in order to describe you the feature, what we are going to be working on, I would like you to use the performance sub-project from Gradle to generate a sample multi-project build. That in that multi-project build, I'm going to demonstrate what we are going to be working on. So let me do that myself. So our performance sub-project contains some useful utilities to generate projects. And this project is going to have 25 sub-projects. And I'm going to be using them to demonstrate to you the problem we want to solve and the feature we want to do. And I guess it would be nice to have another session to continue. Okay, so once this is generated, I want you.
Ran that, the performance multi working. Yep.
Okay, so CD into the generated project. So I'm just usually copy pasting that CD into this. And here, what you can do Gradle build, but I want you to use the Gradle that you have installed locally to build that, so that you can see that you can use that Gradle that was very recently built with possibly your changes to run the build. So put that on the path. I'm going to put the path on the path, the Gradle that I have installed. I think users is Faber, Gradle, master, and the rest of the path. Once I do that, and I do Gradle minus V, it tells me that this is a Gradle build. Oh, mistake. Sorry, I need to put the bin directory on my path. Now when I do Gradle V, it says that it's 2.1, and it's 13th of June, which is today. Yes. Okay, so let me just show you all those instructions. So there's a performance multi, there's the export that I want you to do. Ensure that you are using the Gradle version that you have just built. And once you have that, build that project. Okay? And I'm gonna walk around a little bit to find out how are you doing. So let me describe you the problem. I'm gonna run this build with the daemon to show you what are the processes that get started. Let me just use this. I'm going to run this build with the daemon to show you what are the processes that get started when invoking that particular build. So I do have daemon enabled by default. In my home directory, .gradle folder, in the Gradle properties, I have something like that, or Gradle daemon true, which means that every kind of build I do with the daemon. That's going to be important to when I describe you the processes that get started once I run this build. Okay, I'm going to do Gradle build now. Actually, I'm not going to do Gradle build. In a separate window, I'm going to kill Java for now, really quickly. I should have no Javas. Beautiful. And I'm going to run the build. Okay, it's loading, it's compiling, it's configuring. So we have generated 25 projects. So right now I'm going to do JPS minus M. We have a Gradle main, we have a Gradle daemon, but let's wait until it builds so that we have more stuff. Okay, cool. So now what you can see here is that we have a Gradle main process, Gradle daemon process, and Gradle worker main process. Actually, I should do clear so that it's, hang on a sec, let's do this. Okay. We have main, worker, and the daemon. So Gradle main is a pretty thin, small process that does not do anything interesting, just receives messages from the daemon and prints them up to the console. Gradle daemon is the sort of a meaty process that actually does the job. So it usually consumes more memory. It has some default memory settings, like 1 gig of heap. Also, the daemon receives parameter with the version of Gradle that started that daemon. We use that purely for information. So Gradle daemon does not use that parameter at all, but it's useful for you when you inspect the processes. You'll find out what version of Gradle this daemon has been executed. It's particularly important if you work on multiple builds and there are multiple daemons. It's going to inform you what version of Gradle the daemon is using. Okay, and then we have a Gradle worker main, sort of a mysterious process. Anyone has some clue what that process is? As a hint, I'm going to tell you that the sample project is 25 Java projects that have some Java code and some tests. So what's the answer? What's that Gradle worker main? That's a good hint, but not this time. Test. So test, yeah. So by default, Gradle, well, in Gradle, you have to run your test in a separate VM. So I'm not sure if you remember in Ant, the default behavior was that the tests were run within the same process. And we don't want to do that ever. That does not make sense. It has to be a separate process to ensure isolation. So in Gradle, by default, it's a separate VM that runs tests. You can control the forking. You can fork in multiple VMs. You can do parallelization. So you have some options there. But generally, that's the Gradle worker main. So let's spice up this example a little bit to describe it more. So let's see. So right now, when I do JPS minus M, we see only Gradle daemon. So we no longer see Gradle worker main because no tests are being executed. We don't see Gradle main because the other process has finished. Now I want you to run with parallel. Hopefully you have more than one CPU. Sorry, let's do clean build because it's too fast. I didn't manage to do that. So let's do clean build. Okay. Let's do clear. It's still okay, it's running stuff. Oh, I haven't done, did I do parallel? Okay, so take a look what has changed now. So we have multiple Gradle worker main processes. There should be 8 of them because that's how many CPUs I have. I can't And this is probably because the process has just started or something and there's no information, I don't know. But anyhow, we have multiple Gradle worker mains. And the reason for that is when you run in parallel, what's happening is Gradle is scheduling the tasks that are needed to be executed on multiple worker threads. And basically it happens that project 1 has some tests and invokes a new JVM to run those tests, but in parallel, project 2 has also some tests that are being executed, so it creates another VM to run those tests. Hence, we have multiple worker mains. So let's make this example even more spicy. Let's add even more Gradle worker mains. So I'm going to go to the build.gradle file. You can remove everything you see in this in the root project build.gradle file because it only has some diagnostics that we need for tracking memory, but it's not really that useful. And here what I want to do is I want to do sub-projects. So especially for you, Justin, I'm going to enable Ford compilation so that your first answer about Gradle worker main will match now. So, so for all sub-projects, what I'm going to do, every sub-project that has a plugin, Java compile. Now, if you want to find out how to enable forked yeah, let's do Java plugin. But yeah, I'm going to do the task soon, so I just want to show that. So any project that has a Java plugin, what I'm going to do is tasks compile Java, and I want to enable forking. This will mean that the compilation will happen in a forked, completely separate JVM, which means we're going to have even more worker process mains. So if you want to find out how to do that, you can just quickly ask Google. So Gradle compile for Java fork. Here we go. We click here. Beautiful, and we have it documented first. I haven't done that before the session, so this documentation was here already. So you can see compile Java options fork equals true. So let's go back here. Options fork equals true. Yeah, and I want you to run that now, and I want you to use the parallel build, and I want you to see and count how many Gradle worker mains we have. This should work. Like this. I'm going to do it myself. So once I do clean build with the parallel, and I go here and I do clear. Is it building? There you go. Should be more. You got 16. All right, excellent. Because so some of you have 16. It means that you have 8 CPUs. By default, when you run in parallel, Gradle will use 8 worker threads, which means that Java compilation was on 8 separate processes, and tests also on 8. So 16 is good. Okay. So what's the problem that I want to fix? I don't like the fact that I don't understand what are those Gradle worker mains. They have all the same name. So I only showed you the test execution and the Java compilation in the separate Gradle worker main. But there are other things that Gradle does in separate VMs, like the find box, like check style, like other stuff. So the feature that we want to add is we want to add some more description, those guys, to understand more. And first thing what we're going to do is, probably last thing, is we want to find out what this Gradle worker main does, whether it's compilation, whether it's test execution, whether it's something else. So, and this is something very useful, I have to tell you, in large builds, when there are some problems, the build has stalled, there are so many processes. It's very nice to have an insight to what this Gradle worker main does. Anyone had that use case before? No. Okay. Wrong use case. I should come up with something better. Okay. So anyone needs some help with execution, with starting that? Okay. So one way of implementing that feature would be that you could make some changes in the Gradle, install it locally, run this build again to find out. But this is not how we're going to work. We are going to create a test in IntelliJ so that you can very quickly debug into Gradle. You can find out how it works. You can find out the location where we fork the separate process and basically make certain changes. Okay, so let me just quickly go here. Okay, so I want everybody to import Gradle into IntelliJ 13 and ensure it builds. First thing to do is to run the Gradle W idea task. So you get out of the sub-project performance to the main project, just Gradle W idea. Run that and please import that into IntelliJ so that it builds into IntelliJ.
When you do IntelliJ, take the IPR. Don't let IntelliJ do it by itself.
Got it. So when you import into IntelliJ, that's a very good point. So don't use import. When I say import in IntelliJ, don't push import. It's not going to quite work. What you need to do is open the project in IntelliJ. So just open and point to the IPR file that contains the metadata of the project. So,
Does the import work?
Yeah.
so let me, sure. So because when you import, you're going to use this deep integration with IntelliJ, the Jet Gradle plugin, which uses tooling API and which is very nice because it offers syncing and all that magic. But our build is too complicated for that yet. So I mean, like,
So the Gradle version you use is too ahead of what you do.
that's another possibility. So I mean, at some point in the future, the deep integration with IntelliJ, the Jet Gradle plugin, will catch up and we'll be able to import any kind of project. But for now, if you have like really complicated build that has very specific requirements, and we do a lot of interesting things, let's call it this way, with IntelliJ setup, and we can't have them with this deep integration because we basically manipulate the metadata that gets generated and we introduce some things. Let me just quickly show you. I'm not sure. We started at 1, correct? Okay, cool. I'm not sure what's going on with my computer. Anyhow, so use open. So when you generate the metadata, use open and point to the IPR. And I'm going to work around a little bit because, yeah, I'm not sure if this guy will allow me to work. I'm going to kill it, yeah. Oh, hey, beautiful. So I'm going to do it myself. But since I have already opened that project, IntelliJ will ask me whether to reload it. Let me build it myself as well. Anyone need some help? Just raise your hand. I'll walk you. Beautiful. So once you have imported that and opened that in IntelliJ, no, don't use import. Please build it. So just click on the. I'm going to show you in a second. Yep. So one of those buttons here, or just Command F9, I think. And the opening should happen like that. File, open, and then location of the IPR file. There you go, Gradle IPR. If you open that, sorry, not. So file. So let me close project and do it from scratch. Yeah, I see. Doing it. I don't know what's happening with IntelliJ. It does not look very well. It will be kind of hard to work in that state. Okay, so I'm going to open it again. So Gradle SRC, Gradle IPR, choose. There you go. Don't click that. Yeah, IntelliJ suggests to sort of turn on Jet Gradle integration, deep integration, but it's not going to quite work for our project, unfortunately. So if you want to contribute, it's probably better if you use IntelliJ. It's not that we don't like Eclipse. It's just we like IntelliJ more. And then there are certain things that just work out of the box for Gradle build in Eclipse. So And since there's no developer in our team that actually uses Eclipse on a daily basis, it has to catch up with some of the changes we do. So officially we use IntelliJ, and if you want to contribute, please use IntelliJ, because this will give you some pretty nice things like refactoring and code searches and stuff like that. So it's pretty nice. Okay, for me, compilation has succeeded. So I think we can go further. So what I want to do is I want to create a small integration test that will describe that, will show us that problem, but from IntelliJ. We are not going to like invoke Gradle build locally, but we're going to do it in IntelliJ. So I'm going to go to the core, because this feature needs to be in the core. It's sort of core feature. So there are a bunch of sub-projects that we use. And in that particular case, we're going to look into the core.
So sometimes you just need to.
So I'm going to create Groovy class here. Actually, let's put it in some package. And I'm going to call it descriptive worker processes test. And you can follow me. I'm going to extend. Come again?
Key -3 works.
Extends abstract integration spec, I think. Was it? There you go. So this is, if your test extends abstract integration spec, it means it's going to get a bunch of cool infrastructure code for testing, for integ testing Gradle. So I'm going to say a worker process is described. Described. It's going to be Spock test. So we have, in our infrastructure, we have a build file that we can do. So let's do apply plugin Java. So I'm going to explain in a second all that stuff. So we have invested a lot of our time into test infrastructure, so it's very easy to do integ testing in our code. At some point, we're going to put that out to everyone, hopefully soon. You say I say that at every conference. Yes, I know. So
Waiting for that.
it's fair.
That's why Justin's here, though, right?
Fair enough. So, and I'm going to run, let's say, build. So this is something very. We didn't do anything interesting here. Just apply plugin Java. There's no source code, so it's going to just go. But you should be able to run that. So IntelliJ Command Shift F10 or Control Shift F10. It should run that. We should see build successful. So it's thinking about stuff. Okay, we see build successful. And I'm going to add something here. I'm going to add at least one Java class so that we're going to have this separate JVM process that does the compilation. So I'm going to do file, also see main Java. And then class, I need the class name, foo Java, class foo, something like that. Now when I run it again, I should see that the compiled Java should actually pick that up and build it. And I'm going to stop here and wait for you to pick up those changes and ensure that this is buildable in your box. And I'm going to show you how to find out, how to debug into Gradle to find out where we forked that VM so that we can make some changes. Okay, so it worked, and if we take a look here, so compile Java is not up to date, so I assumed it has built it correctly. We're not going to assert on that, but yeah. And then I want to make the compilation to be in the separate forked VM, so let's do that. Compile Java options fork equals true. Something similar that we have done in the sampled project. And I want to see some insight into the processes that have been started. So I'm going to do compile Java do last. Actually, let's do this. Do last. And I'm going to exec. So in Gradle, you have this exec method on a project that allows you to execute a process. If you want more information about that, it's neatly documented in the user guide. I'm sure you can ask Google Gradle exec, and I'll tell you. Actually, let's do that. What I want to do is I want to run JPS after the compiled Java has finished, so that we can see the processes that have been started. So, oh, not yet, yeah, because I need the command line, and then JPS -m, and that's it. And let me just quickly show you Gradle exec. So there's the exec task, which is not quite what we want, but it can show you that there's a command line method. I'm not using the task, I'm using the method. If the method is on projects, that's a great point, Justin. One thing you can do, since we are in the Gradle project right now, we don't have to go somewhere else for documentation. We can just browse the code. So we can take a look at project. Yeah, we can go to we can go to exec method. Yeah, and it explains it executes an external command. It takes a closure that configures the execution, and the closure configures the exec spec. So exec spec gets passed into that closure as a parameter. So if you take a look at the exec spec, we'll see the options, and we see the set command line. We should see also command line method. Right? So this is one of the things I mentioned in my previous presentations that are absolutely critical for being really good at Gradle, is to understand how the build language, the stuff that you write in the build script, glues to the Java code, glues to the API. So like here, there's an exec method. Since by default, you don't have to, in the build scripts, in majority of the time, you don't have to qualify methods on the project. Faster. So yeah, so let's build it. Let's see whether it will do what it should. Yeah, let me just make sure. Cool. All right, let's take a look. It printed some stuff, but I want to make it more prominent. Let's do a print line. All processes. So let's do some ASCII art here. Let's run again. We should see, so the demons are not things that we are interested in. Actually, I could kill them. Maybe not now because the test is running. But what we are interested in is that there's this Gradle worker main here. If I comment out the options fork true, yeah, the compilation will not happen in the separate forked VM. So when I run it, so all processes should not contain Gradle worker main. That's sort of a test whether this all makes sense. All right, anyone needs a hand with that? How's it going? Sure. This is also quite interesting way to debug things in Gradle. If you have reproducible sample of some behavior, you can create an integration test and you can run it so you can see some things. So let's see. All processes, there's it's printed later, so let's remove that. But we don't see Gradle worker main. If I do kill Java, then I'm going to delete those daemons. We should see, and then I'm going to put back options fork true. Okay. Anyone needs help? Shall we move on? Okay, good. All right. So we want to describe that. I want this worker process main to tell us that it's doing the compilation. Okay. So how to do that? This is since you go to the compile Java task, we put a breakpoint in the task action, and basically we'll find out where the whole magic happens. Let's go to Java compile. There we are. Oh, I already have a breakpoint. Beautiful. So the task action annotates like the entry point to the task that gets executed. So if you are debugging Gradle, you have to know some of those things, but I'm going to put breakpoint here. What is very cool is that by default, when you run tests using our infrastructure right there from IntelliJ, and you run them and you debug them, so you do build, you run debug, so it's Shift F9. This Gradle build is invoked in process, having all the classes that you have in IntelliJ loaded, which means that the breakpoints will just work. It's going to be all beautiful. So I'm running it now. So you can right-click and do debug or Command-Shift F9, or depending on your environment, whether you're on Mac or Linux. Okay. It should be a little bit slower, but okay, we hit the breakpoint. If you go back to the test and click console, you can see that compile Java has started, and we hit a breakpoint here. So, oh, sorry, here. Okay. So I'm gonna like move forward, but generally this is a standard. You can learn how Gradle works by debugging and stepping through. You will find out where the magic happens. So I'm gonna do that. I'm gonna just step through. There's a compile method. Let's go there. There's a perform compilation. I'm gonna jump right there to perform compilation method. As we can see, there's a compiler execute method, so let's step into that. There's some cleaner stuff that is going on, so let's move on. And at the bottom, we have compile execute. So we create some kind of compiler instance, and then we execute. Some things are happening. So basically, we are stepping through until we find something that resembles forking off a separate VM. Okay, let's step into, I see fork options. I think we're close. There's a new daemon options, so get daemon. It's going to be either in get daemon or daemon execute. Let's maybe go to the execute method. I don't think this is resolve new. Oh, okay, that was slower. That might be it. I might have missed that. Should be in there, yeah. Okay. So I'm gonna cheat a little bit, but well, we could drop frame. Maybe that's gonna work, or maybe not. So let me quickly rerun the debug session. So like the internals don't matter that much. Once you are debugging into, you'll find out. You'll get your head around that. I don't have like that much time to explain like every single like internal detail that we have. Okay, we have start daemon. Beautiful. Okay, so we found that. Okay. So okay, so this is the place where we build the Java command and we actually start the process. So as you can see, there's a process start. So once you debug stuff, you will find this compiler daemon starter method. So question. So once we found it. Let's think a little bit how we want to describe that. Do you have any ideas how we could describe those daemon processes, those worker main processes, so that when you inspect processes via JPS or PS, they are, you can see what are they doing. Any ideas?
It'd be nice to know what they're doing.
Oh yeah, like that would be cool. But let's focus on something smaller for now. So we want to just know that this guy is compiling Java code, yeah? So do you have any ideas? So we want the JPS, when I do JPSM, let's say, that's my criteria. I want to see more information into what is this guy. So one way of doing that would be to change the name of the class, right? So that when we invoke the process for compilation, it's called Gradle worker compiler main, for example. And when we do test, Gradle worker test main or something like that. But that's not really convenient because we would have to have those fake classes, or we would have to generate them. It would be not that friendly. Any other ideas you might have? So another thing what we could do, we could pass standard Java parameter with that Gradle worker main. At the moment, Gradle workers don't consume any parameters. Gradle worker main receives a serialized action that is executed, so it does not consume any parameters. We could just pass a standard Java argument, just like Gradle daemon gets a version of Gradle. This worker main won't consume that information at all, but it will be seen in the processes list. It will be kind of nice. So let's see whether this would work. So we have the Java command here. So I'm going to let it run, and I'm going to do something like that. Java command, args, and let's say, hey. Right? As you can see, I can run the test now. So I'm going to go back to that class so that you can see what it is. I'm going to run it. So I'm not going to debug anymore. I'm going to run it, and let's see what the JPS command shows us. What's great about this way of debugging and working with Gradle is that you change the class and you can just rerun the test. You don't have to install Gradle somewhere to check whether your change is there. You see, we have Gradle worker main, hey. So we are able to pass information to that Gradle worker main. So I want at least someone have that ready so that we can have this pull request. Come on, guys. So. And I'm sort of going forward a little bit more. So we don't want hey. We want something reasonable. And
How come it's not part of the JVM of the...
come again?
What are those arguments? So those arguments here, they are not used to actually execute anything.
So yes, Gradle worker. Okay, the question was about the arguments, whether they are used or.
Yeah.
So this hey argument is not used. It's not consumed at all by the worker main.
So wouldn't it be better to pass in a system, I mean, that system property or something, because if Java worker main ever does accept some kind of property, it would...
We would have to change the strategy, yes. So, or we could make a rule that the first argument is information only, for example, and the second argument does something. So yeah, but currently we can use that. So we can use that argument. In future, we might revise that strategy.
But it's not going to make it any difference for backwards compatibility?
Not at all.
Okay.
Not at all, because Gradle worker processes are completely internal. Cool. So, okay. So let's put a reasonable name here, okay? So I could do something like, so this is a compiler daemon starter, so I can just do I'm the compiler. I'm going to rerun that. So it's going to be better. It's going to tell me that I'm the compiler. So, but this is not so nice. If you take a look closer, you're going to see that we have a builder that builds this sort of a process builder, and it sets the base name. Okay. If I scan the source code, in what places we set the base name for when we use this machinery to build workers, you can see that we use it here for the Gradle findbugs worker, for the Gradle random worker, for the compiler daemon, for the Gradle test executor. So let's make our feature generic enough to work with other worker processes, not only this one. Because if I do it here, obviously I'm going to the Java compiler process will document itself in the process list, but all the others won't. To do that, what we can do is we can go to...
compiler daemon is used for other compiler, like Scala, GCC, and stuff like that?
No. I mean, Scala and the other places, we also support forked compilation, but just not that class is handling that. Okay? The question was whether whether Scala or other machineries use this class to compile now, but we do support fork compilation for other tools as well. Okay, so we set the base name in the worker process builder. So let's find out here. Oh, there's a Java command here that gets built. In theory, what I can do is I can Where we build the worker. Oh, it's abstract, so let's go there. So this is where we build the worker. We even say that set the display name on Java command. So somewhere here what we can do is I'm going to do args, and then let's say we do this. I'm using quotes to make it nicer because the display name has spaces, so it looks good. So if you drill down into what the compiler daemon does, you'll find out the default worker process factory that also sets a display name on the Java command. We could add an args and display name here. So let's see how it works. And I need to officially confess that we are not going to finish the pull request today. But at least you learned some stuff. I think the pull request is like...
One quick question. So we're basically testing by running something and looking at output. How would we, ideally what we would do is that would be red. Because the worker main. So how do we get the string out of the command line from the build file?
How do we? Okay, the question is like more generic.
Process, right?
How do we test it properly? That's what you're asking.
Yes.
Okay, cool. Thank you for that question because I might forget that. So I wouldn't include that test in the pull request, not at all. There are a couple of things that I really don't like about that test. Like JPS could not be on the class path, on the path, right? Scraping the output, it's kind of nice, not a nice test. So let me just get back to that question. But first, I want to just see. So as you can see, Gradle worker main says Gradle compiler daemon 1. Okay. So if you make that change into the default worker process factor. Oh, actually, you're going to have a homework from that. So I want to see pull request from someone about that. And you can, one thing I'm going to, you don't have to submit any tests for that, just the pull request with that change, and we'll see whether we're going to like it. But generally, there's a chance we're going to merge that. But let me go back. In background, I'm going to install Gradle so that we can actually see how it works with the real project. So finally, to do some end-to-end testing on the real kind of big project, you can then install Gradle and see how it goes. But to shorten the dev cycles, to have a quick feedback cycle, please use those integration tests inside in IntelliJ for Gradle so that you can quickly debug things and try test. Okay. So this is building. Let's go back here. So some ways to make this test better. Okay, we could, in theory, ignore this test if JPS is not available, let's say, right? If it runs on, I don't know, environment where it's not there. We could scrape the output to find out whether the name is there. We could, what else we could do? We could add some logging to the compiled Java, or to maybe somewhere deeper into this class that builds those workers, that it logs information, what are the arguments used. But I would be probably tempted not to write integration tests on that feature because to me, what we have done, we have configured the Java command. So it's not really kind of meaty imperative logic with if statements, with interesting logic to unit test, to integration test. It's more like configuration. It's hard to test. That's another good argument.
I guess my question really wasn't about this specific feature, but more generalized. Like for something like this, how would you?
In that particular use case, I would not write integration tests. That would be my stance, and I might have received a code review item from Adam. Where are integration tests? Come on. So that is a possibility. But I don't think we have. For example, I don't think that we have coverage for the fact that Gradle daemon has a Gradle version as a first argument. I doubt that we have that. So this is also, we have a bunch of integration tests that ensure that forking of processes works. So we are not going to break stuff with that. That's for sure. If I don't have it covered, that it shows this little information, I can live with that. Maybe one night with a little bit of crying, but that's it. but that'll be fine. Okay, so it installed. Let me run the multi.
Could I make another request then with
Sure.
regards to that? Could you review some good examples of unit tests and stuff though for different kinds of problems that might be helpful as examples?
Could I review right now?
Or do we not have time? I mean,
Oh, no,
just
sure. We can
one-
take a look at the
you
unit
like
test.
One unit test that you're like, this is like
Beautiful.
the awesome unit test. that
Yeah,
you
so
can say.
I'll look into Luke's history of commits, and the first unit test on the list is probably going to be an awesome unit test. You can also go back to GitHub history and find out the first unit test created to Gradle. It's probably going to be a JMock test with 30 or 50 mocks. So it's not going to be a nice, good example of something that that you want to do. Generally, tests are very nice quality and unit tests. So there are just a little bit of legacy test code we have. Those are typically like old JMock tests. JMock is obviously beautiful, perfect library. It happens that some of the tests are ugly, but then we gradually get rid of them. Basically, whenever we have to touch a class that is tested with some old JMock tests, we make an effort to refactor that. Those are also pull requests that we will gladly accept. Some of the rework and refactoring in our test code. But there's not much. I would say that 95% of the test code is really, really nice. It's really nice. So, but okay, if we have time, I'll take a look at one of the unit tests. Okay, let's run that. So Gradle parallel, a clean build. Gradle clean build parallel. So I'm going to run that. And let's see how it goes. So seems to be building stuff, so okay. So you see it's slower. It compiles stuff in the cache because we are using the different Gradle versions, so Gradle does not reuse the caches. Okay, we have Gradle compiler daemons. Where are tests? I'm not sure why I don't see tests. Oh. So let's run it again. Maybe we do have tests. So okay. I see only compiler daemons. Yeah, so we have some tests executed. I was executing JPS -n when there was nothing tested. But you can see that now the worker processes describe themselves. So there you go now, quickly pull request, and we're going to merge it and all good. And then builds just goes red. The build can go red because nobody is developing right now, I guess. Everyone is at the conference. So yeah, thank you very much for the comment about that test, because I don't want to get you the impression that this is something we would accept. We want to have clean tests and not like that. We kick off some processes, we don't even know whether they are on path or not, and then we scrape the output or whatever. So for many features, we write a really nice, interesting fixture code that allows us to easily assert on things.
And we distribute those fixture to everyone, right?
Yes. The test framework liberation group.
So just to expand on that a little bit, the testing point, can you point to some good examples? If we had more time, that would be a really useful thing to do. But all of us in the team pretty much take the stance that the quality of the automated tests are the most important thing about the code base. Focus on good quality tests first, implementation not so much initially. So I guess we all kind of consider it a bit of an art form, and it's an item of heavy debate when we're working on something is the test coverage. So if you're asking in terms of contributing to Gradle, let's say just contribute a test, something, and then basically we'll look at it and say, no, let's do it this way instead. So don't kind of shoot for the moon initially, because we don't. We just get something going, and then Szczepan would commit this, and then I'd give him a review saying it's absolute rubbish, get rid of it, kind of thing. So
It doesn't happen. It doesn't happen that often.
So do you have your kind of test infrastructure documented at all? Like your kind of your guidelines and fixture setup or any of that kind of stuff?
So the question was, do we have our test infrastructure documented? And we do, but it strikes me now that it's internal, which probably doesn't make much sense. So people onboarding onto Gradle, we have some stuff set up. So we could definitely do a better job there because it is a bit daunting. I guess we put a lot of work into the test fixtures. So that's something I'll take away. That is something we should do a better job of.
Well, the plugin test fixture doesn't have to be the same as this integration of the description.
Question was, the plugin test fixture doesn't have to be the same as this. No, and it probably shouldn't be. We have to test for different kinds of things than what plugins do. Because we're testing how does Gradle work when it's being executed as a process? How does it work when it's being executed as a daemon? How does it work with this file system encoding? What does it do when the operating system has mandatory file locks instead of optional file locks? So we have to test for different kinds of things than plugins test for. And that's why, I'm not going to offer this as an excuse, but one of the reasons why we haven't done a good plugin test kit is that what we have here is not really suitable for plugins. Yeah.
We need to hire more test tool authors, I think. We just have like 3, like Jeb, Mockito, Spock. We need like few more, and then there's going to be enough push to develop that. I just opened one of the integration tests. Not sure if it's a great example, but as you can see, it's pretty clean. So there's some external script. We expect it to fail, and there's this sort of a clean assertions that we assert on certain happen. But really, we have various kinds of tests. That's just one of the opens. And all the strategies of writing clean code apply to the test code. I'm also a strong believer that, and we all, I think that if you care for cleanness of your test code, you have to write clean production code. Because like, especially unit tests, right? If you want to have clean unit tests that are, small, they don't use 20 mocks, but like 3 mock objects, let's say, or 4 maybe. And you have the code needs to be clean, needs to be decoupled, needs to be nicely responsibilities separated into the separate objects and stuff. So that's why we care very much for the test quality, because it pushes hard the production code quality to be also high. So any questions you might have? I don't see pull requests yet, guys. What's going on? The question was about the temporary folders for the test. Yes, it's all hidden in our infrastructure. So by the fact that we extend this abstract integration spec, we have that. So that's why I don't do clean build here, because every time I run this test, it's going to be in a separate directory. And we have a bunch of other cool stuff. For example, we have abstract base class for the test for the dependency management tests. And we ensure that there's no Maven local repo that is hanging, or we ensure that the Gradle user home is clean, does not have any cached version. So there's lots of things we have in our infrastructure, and we're going to share them soon. Yes, we will. And so we are out of time, but like one last question you might have. Yeah. All right, thank you very much. Enjoy the remaining parts of the conference. Thanks, Luke.